In this video, I have another collectAllPar example that I want to show. And this one, again, is going to show the difference between something like collectAllPar and doing things in parallel versus collectAll as a way to demonstrate collectAllPar's concurrency. So I've got a few things going on here at the beginning. The first one is I have this function here named current time in millis, and that's what it does. It gets the current time in millis using the ZO clock, and it returns that as a UIO of long. I have a type here, and this is a little early, I think, but basically what's going on is in some cases like here and here and somewhere else down here like that, we're going to be using this type Rio of random string. And the reason I created this type alias is that these types might get a little difficult to look at if you're not used to using them. Like in this example here where you have a list of Rio and random of string. If that's a little bit difficult to read right now, we can use this type alias. So we'll take a look at that in just a little bit, but that's what this line is right here. Then I have two functions that simulate things that we'll do in the real world. This is making an API call. So it takes a parameter named ID, and that's an int, and it has that Rio return type that I just mentioned. And this is going to be similar to previous examples, except here I use random to get the next int between these two values. I say that I'm making an API call, then after a delay here, I succeed, and then I print that message. And then this function is very much the same. I also use random, has slightly less time, but I do basically the same things inside of here with another delay right there. So again, this function and this one are just simulated. Delta time is a function that we'll use in here to get the delta time or the change in time as we run things. And now we come down to our main application. So what I'm going to do here is have this list of calls. And again, that's this list of Rio, of random, and string. And what I wanted to show was that if that is too difficult to read, that Rio, random, a string, you can do something like that. And again, this name may not be perfect, but I just wanted to indicate that this is a ZO and the REA values are random, throwable, and string. That's what I wanted to indicate right there. And I think this is a little bit easier to read than what I had there before, so I'm going to leave it that way. But either way, this creates this list of these values. So you can see I'm making two API calls with number 1 and number 2, and then I'm calling process file with number 1 and number 2. So that's our list of calls that we're going to make. And then when I come down here, we have two values here, this one and this one. This one here runs things sequentially. And what I mean by that is it just calls zo.collectAll right here. I think these functions are exactly the same or almost exactly the same. But this one uses collectAll, so it runs sequentially. And then this one uses collectAllPar, and it will run concurrently. And everything else in those functions is exactly the same. So you get the start time from this method up here. There's debugging code there. collectAllPar runs things concurrently. Get the end time right here. Then we print some debugging code, including the delta time for that. And another thing I show here is using zo.forEach. So I've shown this, I think, in videos a little bit. But what this does is if you come over here and you look at these results, you'll see that that's a list of string right there. So we can use zo.forEach with a list of string right here. And we use forEach when you have some type of side effecting thing going on. And in this case, I'm printing to standard out. So this is a typical use case for zo.forEach. And as I mentioned, this function is basically the same as that one. And then we come down to the blueprint. So what I'm going to do here is I'm going to run the concurrent one first, and then I'll run the sequential one second. And one more thing I need to note is that I'm using the blueprint here. I haven't used that in a while, but I use that because I wanted to do a .provide. And I do that so I can provide the ZO random environment as a dependency to the blueprint. So that's how you do that with this .provide function. And I've shown this in previous videos, but typically you'll have something like that .provide. And then after that, you might have something like fold ZO to handle the result here. So that's when we have the failure case here. And then we have the success case here. That's the type of code that I've shown before right there. So the way this works is that .provide provides your dependencies, one or more dependencies, to Blueprint, and then Blueprint is able to run with those dependencies. So that's why we have this random here as the environment parameter, because I'm passing it in here with .provide, and then I'm declaring here that my code here needs the random library to run. So that's .provide, which gives that dependency to Blueprint. And as I mentioned, once Blueprint is finished running, then we handle its result, typically with something like fold 0, but in this case, I'm really not going to do any type of error handling like that right there. So given all that, let's come over here and run that. And again, it's going to run the concurrent example, then run the sequential example. So here goes a concurrent one. You can see the API calls, the file processing, and the current example completed actually in exactly 4 seconds right there. Now it started the sequential one, and that one is still running. And you can see the sequential one took over 13 seconds right here, and the concurrent example took 4 seconds right there. So that is quite a bit of a difference between collectAll running sequentially and collectAllPar running concurrently. One other thing I want to note, because this is a functional programming course, is because there's so much repetition between this function and this function right here, what you could do is replace those guys. So I could comment them out, I suppose, if you still want to be able to see those, like that. And then what I've done down here is I wrote the other version of that, which is much more functional. So let me copy that. So this has nothing to do with parallel and concurrent discussion. This just has to do with functional programming. I want to be clear about that. So now what I've done here is I create a different function. I call this one run with, and it takes this parameter I call a strategy. And it takes in this list of Rio values and it transforms those into a Rio that has this list over here. And I talked about this earlier before about how collectAll and collectAllPar, they transform a list of ZO values or Rio values like this into a Rio or ZO that has a list over here. I feel like I'm not explaining that very well, but it's taking a list of ZO values as input, and then it's returning a ZO value, and the success value over here is a list. And that success value comes from the conversion of whatever you're converting with collectAll and collectAllPar. But anyway, coming back to the functional programming part, I take in the strategy here, and that's a function that transforms this type into this type. And then I execute that function on a list of calls, just like we did previously. And now the key is that strategy is what you pass in. It's the function that you pass in. So when you want to run things concurrently, you pass in collectAllPar as the function. When you want to run things sequentially, you pass in collectAll into run with. So again, this is kind of a bonus part that I'm talking about, and I just wanted to show how to write this function in a more functional manner. And that is that it takes another function as input, and we can use this function in this case, this function in this case. And that's compared to all the duplicate code that I had up here and all through here. So let me save that and just demonstrate to you that this works. And here we go, we're off and running. And you can see the concurrent example completes in less than 4 seconds. Those two take about 4 seconds each. And there we go, that's finished in just over 13 seconds total. So as a quick recap, what we did in this video is we looked at the difference between collectAllPar and collectAll, and you saw the difference in those runtimes over there. And then as a little bonus, I showed that we can reduce all of this duplicate code here to something like this by creating a higher order function like run with, where we take a function like that as a function input parameter, and then you pass in the two functions here and here. So I hope the original goal of this video was helpful, and then I hope this bonus code was helpful as well.